I hope I'm audible, clear. Thank you very much for everyone's time, and it's pleasure meeting with you all. I was thinking about what topic I need to talk to when Dylan and the team here contacted me, and after some thought, I picked this topic due to a combination of my passion, my interest in Android and cell phones, where I have been involved earlier, and of course taking it to newer areas and newer applications, and essentially helping the people and helping the mankind, right? That plays an extremely important role in any technology that we develop. So that's where I thought I'll blend the two and share some of my thoughts. Certain things are already happening in the industry, so I hope it'll be a near reality from what we are seeing, and it is also an opportunity to share what we as a company in Analog Devices does in not directly, but to a lot of electronic fraternity, and that's the reason why I chose this topic, which is a jugalbandi, as I call it. I lead some of the engineering aspects, the applications and the systems engineering at Analog Devices in Bangalore. Interestingly, you will figure out Analog Devices is not into doing any mainstream work on Android or any of the cell phone or anything, but you will also be surprised there is a lot of semiconductor content that goes out from Analog Devices into these newer products, starting from as simple as a MEMS microphone all the way up the value chain. So before I go through, I thought it is necessary for us as a company to share about what we do, and also just introduce some of the key technologies and key products that we as a company employ. So we are close to 40 years plus of existence. We are a Boston, Massachusetts based company, and we focus on signal processing solutions for our customers, and that is the key strength. We have been there, both be it any product that is related to signal processing, we tend to play a role there. We have evolved from being a pure analog company to a DSP company. We also used to do the GSM handset chipsets earlier before selling it to MediaTek, which is a Taiwan company. But nevertheless, subsequently we refocused ourselves on certain key signal processing areas, and they make a relevance, which I'll talk to you very shortly in my talk. And we are $3 billion in the financial year 2011. So we are spread across a number of countries, close to 23 countries we have presence, and India also has a good presence in terms of engineering and sales as well. We do quite a bit of digital and analog mixed signal MEMS engineering design activities, as well as applications activities based out of Bangalore. So as we speak, right, when Analog Devices started, it all started in the analog domain. We were still doing a lot of analog signal processing at that time. All the communication systems were analog. All the controls were analog. There is no digital at that point of time that was picking. But then the real opportunity and the challenge exists when we move into the digital domain. Something as simple as a converter plays an extremely important role. Analog Devices actually has its converters used in the Mars rover and the newer one, right? So they're very critical. They play an extremely important role in this whole analog to digital domain as you take things forward. A number of products play an extremely important role, and as systems get complex, your signal chain starts to expand, and analog has a wide portfolio of products that meet a lot of these requirements. So as we speak, right? I mean, any typical application, be it a cell phone or be it a very simple data acquisition system, you are essentially talking of a signal chain that looks very similar. You have an analog domain, you have a digital domain, you need the converters, you need the right amps, you need the sensors, and in some cases you will also need the matching circuitry. You need the power management to give you the best power, which is critical for many battery applications today. You have the control and the MCU piece. So we have the signal processing, and then now we are adding a lot of control capabilities. However, I think analog is not a complete end customer product company. Analog is a technology company providing signal chain solutions. So we are a silicon vendor. So being a silicon vendor, we do focus on providing a good solution in the form of reference designs for our customers. We do quite a bit of packaging work so that we integrate into a single system in a package, SIP package, silicon in a package. We have had instances where we actually integrated complex things, where we have a few passives, we have a DSP, we have an MCU, and then we have memory all put together in a single package. Obviously, we are passing the benefit of cost and the board area to the customers. So that's something which, as a company, we do offer. And then, of course, at the DSP team works on the SoC, complex SoCs starting with signal processors. And of course, we are also having quite a few products coming out with ARM, where we try to bring in the best of the ARM MCU, which is giving you a standard platform, and with some of our analog IP integrated. So that gives a good cost value proposition for our customers. So we as a company has traditionally been a very broad-based 60,000 products, 10,000 products, 60,000 customers type of a business traditionally, and we still continue. We have wide variety of products cutting across domains, and we have a large number of customers starting from say a fingerprint authentication modules, going up all the way to defense. However, I think, as you will see, right, when we have designed the products, you would have designed the products for certain application, and then you will start to see customers retargeting that. So as a function of time, we have matured as an organization. So we started to define certain key areas, as you have seen here: automotive, communications, consumer, healthcare, and industrial and instrumentation. So those are the key markets that we address. And the key technologies that really take us to these markets are these. And of course, I come from the DSP and the processor group, but nevertheless, I represent analog devices. So we do have converters, MEMS, power, linear, and RF, all these different technologies. So we try to see how we work with these technologies and meet with a number of these customers and beyond, of course. You would also see that I have marked some of these in red colored boxes. The intent is to share in the context of this talk today, it is some of these areas which I am going to touch, where beyond a cell phone, Android does have an impact, and that's what we are seeing today, and we continue to see the progress. And I would also like to take the opportunity as I go ahead to introduce some of the products that play an extremely important role. Again, as I said, we have a number of segments. We do play an extremely important role in the I&I, industrial and instrumentation. And one of the key areas which I'm going to talk about is in the area of building technology, where Android will play a big role, especially if some of you who would have seen the smart homes coming up in Bangalore and around. It is only a starting point, and we believe that there is a lot of value you can add over a function of time in that area, and we do have some of the products that meet these requirements. The automotive is an extremely important segment for us, and then we play a very important role in coming up with ADAS, a driver assistance system. I'll briefly share with you some of the products in ADAS, but again, that's an extremely important piece that a country like India can play in the automotive, because not everyone has a high-end car, and the way you can enable Android to come up as a very, very cost-effective solution, because thanks to its scale and bring certain innovative solutions in these areas, that's something only I think a scale of a cell phone or a system like that will make it happen. We also give solutions in the stability control and airbag systems, but I'm going to talk a little bit about the ADAS in the subsequent slides. We also have a healthcare team, and again, this is another extremely important area I'm going to talk about, very relevant for a country like India, to talk about how Android and the cell phones can actually play an extremely important role in areas like vital signs monitoring, and some of the home health systems, and help a lot of the people in the country, as well as a great business opportunity for us. So we do play an active role. We do have some of the cutting edge products in the healthcare, and I'll briefly talk about some of the key technologies there. So as I mentioned, we are spread across a number of countries and number of locations. In India, we are only in Bangalore. Of course, we have satellite offices in Delhi, Bombay, Hyderabad, etc., where we have our customers. We are based out of Massachusetts, Norwood, where our worldwide headquarters exist. We do operate some fabs in some of the analog manufacturing. For example, our MEMS is manufactured in our internal fabs, MEMS solutions, and but a lot of digital, we work very closely with TSMC in Taiwan. We have a lot of field teams spread all across the world, as you can see, to get the best of the support. And the India support team is all based out of Bangalore here. So to enable our customers, we do provide a bunch of tools. We give a lot of support for our customers in the form of reference designs, apart from, of course, the part selection, which is critical. We do provide a number of simulation and software tools for our customers, most of them for free. We also provide good support, as well as a community engineered zone support, where you can talk to the fellow ADI engineers in the forum and take self-help. So you would see, being a breadth of the portfolio of the products, it becomes a single place where you could actually get the products and then start to work in a number of designs. Briefly to introduce about analog devices in India, we started in 1995, so we are 15 plus years in India. We started with 10 people actually. We took the ownership of a product called Shark, which I will briefly talk about in the subsequent slides. Then we added capabilities in software, product applications, we mix signal, product and test engineering. We do the blackfin design, and of course system level IP development team, and MEMS and high speed ADC and high speed converters teams. So this is pretty much bulk of ADI's portfolio, and we have had a number of innovative products come out of the team here in India. Just to let you know, way back in '95, we started with the Shark processor at 40 megahertz, and with keeping it code compatible and keeping the architecture pretty much similar, but with a lot of enhancements internally. We have taken the complete ownership of Shark to around 450 megahertz today, and that's like 10x increase over the last 15 years, and there are more products in the pipeline with higher performances. So the team in India completely owns some of these key technologies, and we drive the solutions in this space. So with that, let me quickly move into Android, which is one of the topics, and the past introduction about analog devices and Android are orthogonal, but you will see as we go further in terms of how you can combine the technologies and build innovation, right? So as you will all know, Android is something that Google has developed. It's a stack, it's a framework, it's a complete solution. It's just not the OS, but there is a whole lot of things beyond the OS that it is encompassing. It's a middleware with some key applications that are there. And as you would see, it all started way back in mid 2000s with the Google's intent to develop certain framework which could be used in the handsets. That's their primary intent when it came up. However, you would have seen by now a lot more variety of devices coming up with Android. I briefly touch base some of them later on, but beyond the cell phones, in cell phones it is very successful, and beyond the cell phones it is making inroads. The primary reason why this is heavily successful is because it's an open OS. Unlike other operating systems or other frameworks like a BlackBerry or Apple's iOS, or even Symbian until very recently when Nokia opened it, Google has been pretty much very clear about keeping Android completely open right from day one. So it is this openness that enabled innovation in a significant way, and that is actually giving leverage for people to think about a lot of different type of products, and when we talk to our customers, we see they come up with really new ideas using some of our technology in Android. Now what is more important also is Android, as it is open, it comes for free, so makes it better, but it also has its own set of challenges. There is too much of fragmentation. Being it open, if you are trying to get into some of the areas of improvements you do into the source, you need to contribute back to the open source community, which means some of the IP has to be very carefully guarded and taken care of, which makes sense, of course. And of course, being open also means that it may not always be the most efficient one when you consider in a consumer industry where costs are primarily of importance. So for example, are you getting the best code size? Probably yes, or probably no. Do you have everything very efficiently implemented? Not necessarily. So you have its own set of challenges. But otherwise, I think overall Android has been a very, very successful framework, and I'm sure you all know that Android today holds close to 60 to 70% of handset market share, followed by Apple at around 20% or 25%, something around that. So that explains why Apple goes behind Android OEMs, and the biggest one being Samsung, taking up 50% of the 70% market share, right? So or 60% market share. So there is a huge value coming out of the Android devices, and there have been innumerable number of Android devices that have come out, being phones or being tablets, etc. So it initially started as a business alliance. It consisted of the handset manufacturers. It consisted of semiconductor companies, Qualcomm being one of them, where I have worked in the past. So I definitely had a lot of passion working on the Android devices. It had a number of mobile operators as well, and mobile operators is an extremely important piece. Definitely not in India, but abroad, because that's where they could start to drive innovation from a traditional sense earlier where they had fragmented solutions for the handsets and operators are not able to push a common platform of services to their customers or a common way by which all the services are same for all the customers. A solution like Android or iOS is that way very good for the operators. Of course, India is a very different market altogether when compared to Europe or North America, which is completely operator driven. Here you pay 300 rupees and then you buy the 300 MB or 500 MB of data and you do whatever you want. But it's not that way in the Western market. So operators play an extremely important role and they contributed to this. There are a number of software companies that contributed to Android in the form of codecs, in the form of key IP blocks there. So they played a very, very huge role in the success. And of course, you have a number of commercialization and apart from the handset manufacturers. So as I said, analog is not part of the Open Handset Alliance, but we have a big semiconductor TAM that is going in, which you will see in the subsequent slides, and it continues going forward. So this is a brief slide talking about the architecture. This is a very standard slide. I will not even get into the details, but essentially you have got a nice Linux kernel. You have got your runtime, libraries, frameworks, and applications. It is a combination of all these things that is making the whole Android and its ecosystem that much attractive. You can plug and replace the kernel. You can replace some of the frameworks very nicely. You have a number of these ROM vendors for some of these fancy mobile phones, where you can get a new ROM and then replace it so your phone looks completely new. So you are essentially moving away from, say, year 2000 mobile phone where you had a 2-line display or a 3-line display, or even otherwise you had very much proprietary display, to a very standardized display, but still being innovative by changing a few things, changing the user interface, changing the way applications work for you, changing the way applications look for you, and hence effectively you create a differentiation in the consumer space. That's an extremely important piece we should not forget, right? Now one might say that, hey, this looks very much like a PC space, right? I mean, PC also is very similar. You have a HP, you have a Dell, you put the Windows operating system, both look the same except for the form factor. Yes, of course, the PC space, this looks very much like the PC space, but the huge difference between this and the PC is being a handset or being a handheld, there is a lot more things you can do. You don't take PC everywhere you go, whereas you take your handheld, being a tablet or a phone, to everywhere you go, which means you expect a lot more functionality, which means you expect a lot more innovation to be happening. A very classic and a simple thing. You would have never expected an accelerometer in the PC, and even if it is there, it is used for purposes that an end consumer is very much immune to. I mean, you don't even worry about it. At best, you use it to shut down or park your hard disk when you are dropping a laptop. And you don't play a PC game with an accelerometer. I mean, I have not seen one. I could be wrong though. Whereas you have the accelerometer, the same thing taken and targeted on a mobile phone, and you suddenly start to realize you can do many things. You can do a lot of things. It's just not playing a game, but it's about a number of things. You don't take a PC and then you don't expect to use a PC in an extremely noisy environment and talk to someone, but you expect to take a phone and go into a noisy environment and talk, because it's the basic purpose of a phone to be mobile. It's the basic purpose of a mobile is to be mobile, and by being a phone you talk to people, which means the challenges and the semiconductors or the processing that is needed from a PC to a mobile phone is varying. And this is where many OEMs and many people have come up with their own innovations, and that's the opportunity that you will see with such an architecture. So as I mentioned, right, you have a number of applications, and this is only a very small number of these, being an email client or a calendar or a maps browser, etc. And talking about maps, I just want to take a minute and share with you the impact of Android on a number of mapping companies, right? We have had a number of these companies like Garmin, TomTom, you name it, right? I mean, there have been quite a few maps OEMs, and they used to sell standalone GPS prior to 2000, mid 2000s, and they have been a huge success. The models have been that you go to these OEMs, you buy the maps, you buy the service from them. They have a GPS receiver, and they're basically showing you the maps. Today, 10 years from then, you see a lot of these companies getting out of business. You are now talking of Google Maps, you talk of Nokia OVI maps, you talk of Apple coming up with their own mapping. They're all connected, so your internet is making a huge impact here. By being mobile, you can place your mobile and then you start to drive, and with the GPS on the phone, you are now able to navigate around, and it precisely tells you where you are. The cloud services, the cloud servers are precisely telling you from what is the direction, what is the route map from point A to point B. And the best of all, if you take the latest Android, it has a navigation interface on your Google Maps. So pretty much like what your erstwhile navigators had, it just drives you through, including turn-by-turn directions. Huge impact that Android has made to the lives, and now it has come to a stage where you keep adding more and more. You're actually bringing in much more wider applications, right? Something a traditional PC could never make it. Most importantly, doing all this, it enabled simplification because of reuse of components. In fact, on the software, you have seen Android open source. We are hearing about open source hardware as well. So you are now starting to see a significant impact of reuse and emphasis towards reuse of these components, and that is where innovation is coming in, because people are not reinventing the wheel everywhere, right? You have a bunch of libraries, the standard C, C++ libraries, the runtime libraries, etc. Again, something that people have done earlier has all been done by Android, and it is giving you one single source. This is a very, very, I should be honest in accepting that this is a very, very small and a simple set of Android phones. But the only thing I can take pride in telling is this is the first G1 phone which I have also been involved in when I was at Qualcomm. And this is the latest Samsung Galaxy S3. You can see a bulk of phones that have come up in between these, right? So wide variety of form factors, wide variety of processors, wide variety of capabilities as well. Having said that, I want to take things through in terms of what are the challenges that we have seen over the past few years as the phones have been changing the landscape, right? So look at it, around 2008, late 2008 is when the first Android phone G1 has come out from T-Mobile. It came with an ARM11 processor running around 512 megahertz. That's the first phone. That's the applications processor. Of course, it also has a modem and it has a bunch of additional accelerators. But essentially, this is the first processor that has come up. It's a 500 megahertz processor. Over a period of time, the frequency has gone up. You have seen a number of ARM11s at 800 megahertz. They are there even today. You have seen a Cortex A8, which is a V7 architecture from ARM, starting at 1 gigahertz single core. Fairly successful. I bought my phone in 2010, late 2010. It's a Samsung Galaxy S. That's the first phone, and it's a Cortex A8 single core 1 gigahertz. And people call me, oh, it's a low end phone. But when I bought, I paid $1,000 and bought and I thought it was a really high end phone, right? So you can see how the industry is changing, Between here and here, you're suddenly seeing a single core 1 gigahertz to a quad core 1.5 gigahertz. There is a 6x improvement in the processing power and the processing capabilities of the devices, of the phones that are coming out. And we are talking of a 2 gigahertz phones coming out, sooner than later. Chipsets are coming out, and you would see that they are A15s. Hopefully, they are dual cores. Now, this is all not going to change the life of an engineer better, or this is not going to make the life of a consumer either better. In spite of all the processing capability, right? What do you do with all the processing capability? You put it in the hands of a consumer. The biggest challenge is, okay, what does it mean? It means nothing, unless you have the applications, unless you have a lot of things that the phone can do better. What is even worse is your displays are also changing from 2.8 inch to 4.3 inch, which is today. I could be wrong. I agree, it could be 4.5. That's okay. I mean, we are in the ballpark. Which means your batteries are also changing. But then think about it, right? Your phone is going up. Your processing power is going up. Your power consumption is going up exponentially, whereas some of these things are changing only linearly. That is where you will see a lot of optimizations coming in, not only in the semiconductors, but also in the way you design your whole system in the handsets, and also a lot of additional functionality you pack in such a way that it is not consuming so much of power. And that's where we as analog devices do play a role in giving some of the extremely low power components, extremely focused functional chipsets that enable success. So one such application I just wanted to share with you is using a product called Sigma DSP. We have a couple of them. We have quite a few of these things, but I shared a couple of them here. Sigma DSP it's sort of a fixed function processor with integrated ADC, DACs, and some of the power management, low power modes enabled, and filters, a whole lot of circuits and systems inbuilt into a single die. And the nice thing with the Sigma DSP is this is flash based, so you just program it right up front, and it preserves, and it is designed exclusively for a bunch of audio processing. You could do very efficient filters, you could do very efficient FFTs, which are essentially the building blocks of any of your audio algorithms. So effectively, this particular core, which is sitting inside, is helping you do the required audio processing, and at a very low power. Now, what is the biggest advantage of this chip? Why am I talking about this chip? Think about it. In a place like India, where you have a lot of noise on the streets, you're probably talking to someone, and you have a horn honking behind, a BMTC bus giving you a honk. You don't want your other colleague who's on the line wanting to hear all that honk. You want him to hear a very crystal clear sound. You want to do a lot of noise cancellation, both at the microphone as well as in the headphone. The Sigma DSP essentially has the capabilities to do that, and that's where being extremely low power will enable you to do some of these things. Now, is this something that is applicable in a Western world? Probably not, because in the Western world, first of all, you are not going to drive a two-wheeler, very rarely. You should be ultra rich to drive a two-wheeler, number one. Number two, even if you are in a car, your car itself would be having acoustic noise cancellation. So a lot of acoustic noise is cancelled, so you don't need to worry about it. And number three, you will not get into a scenario where you have this changing parameters. You need a lot of adaptive noise cancellation techniques, like in India, where your noise sources are very different compared to driving on a highway at one pace. So we do provide some of the tools and to enable programming the Sigma DSP and tune your algorithms accordingly. And once integrated into the handsets, you have a good opportunity. Again, is this something that would have been done even earlier? The answer is yes, definitely. Is it something easy with a lot of Android and all coming in? Yes, Android and some of these standard platforms have made adopting some of these technologies into the handsets much easier, because the frameworks are designed for scalability and the frameworks are designed for such enhancements into the handsets. A lot of handsets are of course coming out with some of this. A byproduct of this functionality apart from noise cancellation is low power. Why is the low power important? Obviously we have 4 cores and you don't want to run these cores when you are having a voice call, because you are on a mobile, you are moving and you are extremely sensitive about power. So you can actually initialize a call and then transfer all the functionality of processing your call into this, and you can shut off your main processor, the quad cores, effectively saving the power. That's again, you start to see with more complexity, with more power, you still need to save your real power, your battery. Beyond cell phones, there are quite a few other areas which we believe that there is a lot of value. Thanks to a lot of content available in the public domain. I don't need to do the animations and creation of these things. But one of the key areas where we believe there is a great role to play is in the healthcare. Especially in a place like India or many of the countries where human reach is a challenge, but technology reach through airwaves is easier. This is the healthcare is an extremely important role. One such company is a company by name LifeWatch. It's an Israeli company. I think they also have some roots in the US. They made the world's first cell phone, which also doubles up as a mini doctor. It has a few sensors that can do the ECG, heart rate, stress, to measure the temperature, the blood glucose, and of course blood saturation, the pulse oximetry. Of course there is a lot of IP sitting there, so I'm not getting into details of how do they measure some of these effectively or whatever, right? I mean that's an IP of that company, and of course Analog Devices helps that company. But we do have some of the products that are going in there, and I'm going to talk a little more details in the next few slides. We have an accelerometer, we have a temperature sensor that goes into such products, that went into such products rather. Of course, the fancy imagination of people, which might really come true, is to have a number of these components which are stitched either to your dress or on your human body, and you have a hub which could be your phone, which is talking to these devices from time to time and keep transmitting the information to your doctor from time to time. So if you have a person who today you have a person who suddenly died of a heart attack, it's not that his heart suddenly failed at that instance of time. There have been many warning signals that have been either not caught by the person before, or they have not been good enough to be noticed by the person himself. I compare it very similar to a earthquake or a tsunami, right? I mean, we humans do not catch it, but I'm sure a lot of birds and the nature had caught it and then they escaped when the tsunami came. It's the same way. So by having some of these sensors, especially to the critical people, it is not something that you may adopt it, but definitely I think critical care will start to make a difference, and your phone being the center of the gateway, your quad cores doing the processing are going to make a difference in assimilating this data and determining how much of it is a false alarm, how much of it is a truth, and where criticality is required, and hence you do better for the mankind. So we do have a electrode heart rate monitoring solution with the 8232. We have a complete solution which we provide, the signal chain. So you just take it and integrate it into the product, be it a handheld or a tablet or whatever those applications. But with an Android, I think you will see more adoption into these. We do provide the test results. We do provide an entire reference circuits, and we are working to provide some of the software pieces as well. Now, one of the key challenges you would also see is if you have some of these sensors, as I shared in the last slide, how do these sensors talk to the gateway? How would you want them? Do you want Bluetooth? Do you want some other wireless standard? What frequencies do you want, etc. Right? Everything comes with different pros and cons. You have low energy Bluetooth, which is of course existing, but Bluetooth is still very power hungry. The device itself has to operate for a long duration. You don't want it to charge your body devices on your body every 6 hours. And one of the areas is we have an RF101, which is a chip which works on the ISM band, and it's basically something that we targeted for motion sensing, but then you can start to take it and apply it in a number of areas and combine it with many other systems and products and retarget its application. We have an ECG monitoring. This is of course not useful for a cell phone because it's a 5-lead ECG monitoring front end, but I thought since I'm talking about some of the medical stuff, it makes a lot of sense to introduce this. This greatly helps in a number of, it's a low cost single chip solution. All you need to do is connect the electrodes on one side and connect a DSP on the other side. We have a Blackfin 592 DSP. It's a pretty inexpensive solution, very low cost solution. So that is very nicely going to fit into devices where you have a big infrastructure like a dual core, quad core, a gigahertz CPU, 1.5 gigahertz CPUs, and this can do the processing for you even when the CPU is sleeping, and you don't need to disturb the CPU and wake up and take a power hit, right? So you can do a whole lot of signal processing on this very efficiently. We do have some of the accelerometers, ADXL362 and AD7091 SAR ADC, which are again critical for some of these medical solutions that you build in. A lot of this information will be available in our Analog Devices website. Moving from medical, talking about the consumer again, which is another area where we play a pretty big role. Not necessarily from a processor, but a non-processor semiconductor that we play. And when I say processor, I'm talking of the main CPU, apps CPU. So recently, I don't know how many of you may have seen, Nikon announced an Android-based camera. And yesterday, Samsung announced an Android-based camera too. So you may wonder, hey, why the hell you want to have Android in a camera? Well, it does make a lot of difference. Think about it. I have a Canon digital SLR, and every time I take a picture, I go on a tour and come back, I have 500 pictures, and I have to take time to come in, connect my camera to my PC through the USB cable and then switch on. It takes its own sweet time to transfer the content, and I'm actually waiting there for the content to be done. Do I really need to do that? Not necessarily if I have an open framework and with the capability with Wi-Fi where I'm able to move my content very seamlessly from my camera into my server. That's exactly what an Android based camera is bringing you in. What is more important is, apart from this, an Android based camera is opening up the doors of innovation for a lot of image processing and signal processing engineers to really come up with innovative processing solutions, innovative algorithms on the pictures that a camera has taken, which means you are now going to see the camera vendor giving you a certain level of application, and on top of that you will see a number of entrepreneur engineers coming up with very innovative solutions. Now what does it mean for semiconductor companies? It's even better. What you do is you come up with even better innovative products that can actually enable you to enhance a lot of image quality or the user experience in such applications, right? So that's an opportunity beyond just the baseband processor or an applications processor there, but taking it into new levels of user experience and performance that you get out of these. Tablets are one such thing. I mean, we are seeing a constant innovation in the way tablets are coming up from the time the first tablets have been launched. Be it in the software or in the hardware as well. I don't know how many of you have actually followed the latest tablet from Samsung, not the tablet actually, phablet. It's a phone and a tablet together, Galaxy Note 2. So the Galaxy Note came with a very innovative solution called the S Pen, where you can actually write on your tablet, which you cannot do with any of the other tablets other than a Note, just like you wrote on the book. The most innovative thing, and I did not add here because it came just yesterday and I thought it's not fair for me to add, the most innovative thing there is with the Note 2, you take your pen, S Pen, and then just you start an application, and then it will detect, okay, this is a photo, and then I need to open up the photos. Your pen is pointing to the photo or something like that, and then it opens up, right? That's the next level of innovation coming in, which means there is certain level of detection happening in terms of what the user is trying to do, and then the device itself is doing, and that won't happen without a whole bunch of processing and the electronics sitting inside the device. And that's the innovation that you start to see. Analog devices plays a role in some of the components here. We do have Class D solutions, we have HDMI, MEMS microphone, accelerometers, and power solutions, power management. So we have ADP, it's a small charger circuit for both USB and AC charging, which goes into a innumerable number of phones and tablets. And that's where you will see, this is getting more and more popular based on, okay, your phone only has a USB, but then your tablets have both USB and AC power. So you want to deal with some of those features, right? So you support that. The accelerometer is a very prominent one, and you have seen there is no limit to the innovation you can do with the accelerometer. The ADV7523 is another one, which is the HDMI chip. Most of the tablets use this HDMI, and as you can see, right, it's giving you a completely different experience, taking the content from your phone/tablet back into the big screen. And this is a MEMS microphone, and this is a digital microphone, and the MEMS microphone gives you a much better audio quality. And you will see that a whole lot of market is moving away from the analog microphones into the digital MEMS microphones, and we play a role. Talking of the consumer space, again, the most interesting things, the most interesting thing is, hey, where else, beyond the tablets and the phones and the cameras, the audio systems are going to make a change going forward, and you would see that. It's just not Android. It is very fragmented today. You have Apple TV from Apple, you have Netflix, you have got Roku, you have a number of these vendors. But the way I see it is, going forward, you initially had standalone AVR boxes, and then you have the networked AVR boxes, so you can connect an Ethernet here, and then subsequent versions came up with a Wi-Fi version, and you have a DLNA server at home, and then you can stream in the content. Beautiful. What is next? You would start to see, okay, why do I need to go and download some content into my server at home, and then start to again stream in, right? It's an additional step which is not needed. Today, even in a place like India, we are seeing 3G deployed in many places. You hardly find a place where you don't get 3G except you are inside your building. But you come outside, you get 3G in many states. Fairly good connectivity. And places like Bangalore, we start to see 4G, and I for one have a 4G from Airtel, and I get data speeds of 20 Mbps downloads, which means you are now hitting into a sweet spot of I can stream content reliably. You no more have the cables which every other day someone will dig and then you lose connectivity. You don't have that problem anymore, and you also have pricing plans coming up where operators are bundling some of these services and putting all the things together, and that's an enhancement in the revenue for them. Now when you get into that, you cannot be living with the fragmented operating environments and operating systems, which means a open environment like Android will find a good role. And Google has already started taking some of the steps. They have tried a few times, and then they're trying to improve. And one such device is I forget, this is a Google device that was released pretty recently. It's an audio device. You can stream content, music from the network, and you can connect a couple of speakers and you can play. Now then further enhancements could be, you would see this doing a Dolby, this doing a lot of post processing, and then you are starting to stream the real movies and streaming back into the TV, which means at the stroke of your remote you are now going to stream content, and this guy is actually running Android. It understands what you are talking about and then you bring it in. So this is where I think going forward you're going to see. You have the smart TVs already in place. So with Android enabled, and LG is working on the Android enabled TV. So in the same way you will start to see some of these. Analog devices, as I said, has the Sharp processor, and we do offer a good amount of signal processing capability with the Sharp processor. You know, it's extremely high performance, low power, which helps in a lot of these. We also start to see in a very, very small way Android going into the car head unit, and these are the real pictures of the head units in some of the cars I have seen where Android is coming into play. So you no more have a different map experience on the car. You know, what you have on your phone will also come into the car, and you will also soon see that you know, when you go into your car with your cell phone, your SIM profile is completely transferred to the radio inside the car, and it takes on from there. So you have absolutely no reason to even, you know, worry about, oh, I need to transfer this to here, etc. It's a very seamless experience. So as we see some of this intelligence moving into car, a very important technology that ADI has worked to develop is what is called automatic driver assistance system, which is called ADAS. This is a way by which you help the cars. Of course, it is very subjective to understand whether it makes sense in a place like India, where you don't have lane departure, you don't have a lane concept at all. But nevertheless, right, this has a lot of value in the Western world and also in some of the highways in India to detect what's happening in terms of collision avoidance. You detect the lane departure, you detect who is following you behind, how close are they, and then start to guide you, who is coming on the sides, and of course the smart airbag processing. So Analog Devices has a product called Blackfin 609, and that has dedicated video engines that can do this processing. You know, it's called PVP, standing for Pipeline Vision Processor. Again, are these some things that the quad cores can do? Yes, of course the quad cores can do, but then the quad cores are going to cost you a lot, and the quad cores are going to cost you a lot of power, and they are handset SoCs, but not necessarily you know, designed for specific purposes. So by merging, by amalgamating this with some of the low cost Android chipsets, single cores, you effectively make a very meaningful system in some of these application environments. So you know, it's a dual core Blackfin. It has 500 megahertz processing in each core, which means it's 1000 mmax, and it has two max actually, so per core, which is 2000 mmax. The pipeline vision processor can actually help in a lot of computer vision applications, or it's not fair to call computer vision, I should call machine vision, as we see here. So it can do a whole amount of processing, and it also has the right set of interfaces to interface with cameras, display, consoles, and of course it has USB, which enables it to seamlessly interface with many host processors depending on the system requirements. Talking briefly about moving away from automotive / consumer / medical, how about Internet of Things? I'm sure Internet of Things is something that has been discussed earlier, so I wouldn't go into the details. But you know, from my perspective, you have a number of machines, you have a lot of industries, industrial equipments, and industrial automations that are going on. So that's where I think a big play can be attributed for Android again. So these are some of the ideas that we believe I personally believe, and some of them talking to people, which could potentially happen in the next few years. Smart control in every lamp and lights that follow you, right? So think about it. You have a lamp and you have a small adapter which detects whether anyone is there in the room or not, and you fit in your lamp, but if there is no one, you quickly switch off. Of course, I shared this idea to one of my friends, and he says there is already such a solution existing, being provided at a huge amount by some of these big industrial equipment vendors. And it's funny, there is a old lady in their house. She's alone, and she gets up in the night, and as she walks, the lights are getting on and off. She got scared and then switched on everything and then slept with all the lights on. It's like a ghost following you all the while, right? You can get there, but I think there can be a lot of innovation that can happen so that there is no ghost following. But definitely, I think that's an extremely important piece in terms of energy conservation that is coming up. For example, my daughter goes upstairs in my house, she plays with her friends, and she never switches off lights and comes down. And after an hour or so, we detect. So when such a thing happens, this is a technology that detects that, hey, switch off. There is a smart control in all the doors, windows, power outlets integrated with the heating systems and water outlets. That's already happening in the Western world, and you will start to see as the more and more. It just needs us to have a 6-hour electricity cut. We'll all get into this mode, and we'll start to figure out how to optimize. This is the innovative thing that I heard somewhere, where add processing in your pillow to monitor sleep and wake up cycles. Actually, there is a nice little Android app or an Android clock that I have read somewhere a while back. You keep that right next to you when you sleep, and it has a way to detect how many times you have woken up and how many times have you been moving during sleeping, etc. So in the next day, it gives you a graph about how nicely you slept or how nicely you didn't sleep. So there's no end to the creativity of the people, thanks to open source, right? I mean, people never thought about these things before the technology was available. But definitely, I think this could potentially help in some of the innovations. So the key challenges are, the control, the management, the interactivity, user experience, and standardization of systems. They play an extremely important role in enabling some of these technologies to come in, because you don't want different people to do different things, and hence it becomes a very difficult proposition to actually go and implement it. So ADI does, that's where we believe that Android will come in, and once Android or any of these open systems will come in, and you will suddenly start to see a flood of opportunity. And we do have a bunch of products. We have the vibration sensors, we have moisture sensor, we have the tilt sensor, we have the temperature sensors, we have the microcontroller that helps stitch all the pieces together. I spoke about RF101, which is a ISM band radio chip that helps in the low bitrate communications in-house. We also have in a typical advanced control panel in a building control, we have devices starting from charge pumps, proximity sensors, temperature sensor, of course, transceivers, and touchscreen sensors. So in essence, I think to conclude my conversation today, Android has much more wider application base beyond the cell phones. I think it took around 4 years to see that they catch a 60% market share from the time it launched to today. And I think with the work going on in adjacent areas, obviously consumer is one area where it is picking up very nicely. And I would tend to believe that it goes into other areas where consumers are either directly or indirectly involved. As Steve Jobs once said, it's all about connecting the dots. It plays an extremely important role to understand that integrating the ecosystems make a huge impact in making a product successful. For some of us who have a Mac and an iPhone, it's a very seamless integration, doing a lot of synchronization. And the same thing is applicable at a macro scale as well. Creativity is endless, as we can see from people trying to come up with solutions, with ideas. and definitely I think it triggers innovation in a number of applications. We as a company, Analog Devices, we offer a rich portfolio of products and reference solutions, and through a concept called circuits from the lab, where we give reference circuits, and engineer zone, which is a support community, we do provide a good level of support for our customers who want to come up with such innovative products. With this, I conclude my conversation.